We're now ready to begin routine data collection. The first pass we're going to show you is the joint collection at the center line. To do this, we're recommending that your closest sensor, in this case the rightmost sensor, is 6 inches away from your longitudinal joint. To input the correct information, it's the same as when we did the validation from a stationing perspective, where we're starting at station 655, so we keep that where it's at, and it's 655 plus 0, 0, so we'll also keep our starting distance at 0. We're still going in increasing stationing direction, so we'll keep this portion unchecked and still traveling in the travel lane. The difference now is, you see, we want to input a negative 2.5 feet. The reason we do that is because we're always telling the software where our centermost sensor is relative to our reference line when looking up station. So in this case, our center sensor is 2.5 feet to the left of our reference line. So we're putting a negative 2.5 in this location. As you might be able to tell from simple math, that means that our rightmost sensor is 6 inches or 0.5 feet away from the center line. So we're happy with that designation, and we'll keep our lot and sublot uninput and move along to the file root name. Now, rather than having the -113 like we had as part of our transverse line test, we're going to delete the 113, which tells us we're back into routine data collection. Now our file root name is 061 for our route name, -1 for what current lift we're testing. At this point, we can press collect data. Once our sensors are lined up at the starting station location, we can actually press collect distance and begin collecting our pass. You know you're ready to collect data when you see the file name here, and you can also notice that the software automatically appends a counter at the end, a 3-digit counter, and that just keeps track of the unique file names as you collect them on the project. Before we begin our joint collection, I just want to point out one simple thing that we do to make sure that our sensor is 6 inches away from our joint. You'll notice that this sensor right here is at a negative 1.5 feet according to our scale on our bar. In that case, we want our zip tie to be dragging along the joint when it is at negative 2.5 feet, which is 6 inches away from where our sensor is. So one thing you'll want to do is just make sure that your zip tie is lined up so that it's not skewed when it's dragging along the joint. And when you have it pretty good, you should know that as long as your zip tie is dragging along the joint, your sensor is relatively close to the 6 inches it's supposed to be during data collection. So now we can begin our joint routine collection. We're now going to demonstrate the joint data collection path. After pressing collect data and collect distance, we're ready to start walking forward. As I walk forward, I'm going to see data coming into my screen. The main thing I need to do during this pass is ensure that this zip tie is dragging right along the longitudinal joint. This is going to ensure that we have a relatively accurate assessment 6 inches away from the joint. This allows us to ensure that we're going to get a joint compaction reading without having any impact from the edge of the pavement itself, which can skew the reading in one direction or another. So by continuing along here with our zip tie dragging along the joint, we're going to be reaching approximately 150 feet from where we began. At this point, we can stop and save our data. The next pass we're going to complete in our routine data collection is a swerve data collection. In this case, we're going to put 656 in our starting station and 50 in our starting distance. We're also going to change our lateral offset to -35 to indicate that we will be swerving to get a random sample of the mat. At that point, we can press collect data and collect distance. And as soon as we see collect file, we're now going back towards the direction we came from. And it's recommended with this swerve data collection, whether you're completing it for validation of the sensors or for a random selection of the mat, as we're demonstrating now, that you want that outermost sensor to always be approximately 2 to 10 feet away from the closest joint. In this case, our right sensor was getting close to 2 feet from our shoulder joint, and now our left sensor is getting close to 2 feet from our center line joint. And once we hit our turnaround point, which is typically around 250 feet, in this case it's at 150 feet, we're going to start moving back. And again, you're just going to go back and forth until your outermost sensor is approximately 2 feet away from the closest edge. One benefit of using this type of a routine data collection pass as a random sample of your mat is that beyond it being something that can't be assessed by the contractor and gamed, it also can double as a way to validate that your 3 sensors are measuring properly. So basically, by completing this pass back and forth, we've not only got a good random sample of the mat, but now after stopping and saving, we can actually look at the data too to make sure our sensors are still functioning properly. At this point, we're going to now line up the sensors so that we're collecting on the joint on the shoulder side of the lane. So in this case, we're going to go up until we get to our starting stationing, which in this case is 656 plus 50. So I just input 656 in the starting station and 50 in the starting distance. I'm going to select decreasing distance, and I'm going to input a lateral offset of -9.5. -9.5 is the distance from our reference line to our center sensor. This being a 12-foot lane, sensor 115 is then 6 inches away from our shoulder joint. And we don't need to change our file root name. That's just going to continue to populate up as we run our different passes. So now that I'm at the starting location, I can press collect distance, scroll down, make sure that my collect file name has showed up, and I can begin collecting back. And I'll see the data coming in. And as you can see here, this is not exactly representative of a shoulder joint, but we're just making sure that our zip tie is dragging on the outer edge of our pavement here. And you're going to do this data collection for the entire 150-foot stretch along this lane. Once we get to the end of our stretch, we're going to press stop and save. And now we're going to position our cart for the final pass, which is right down the center. And in this case, we just need to go back to our starting station and indicate 655, starting distance 0, uncheck decreasing distance because now we're moving in the increasing station direction. Our lateral offset, which is the distance from our reference line to the center of our, to our center sensor when looking up station, is -6. And we don't need to touch our file root name, that'll automatically count up. So now we scroll down to collect distance, and we see our file at the top. We can start collecting data forward now. And with this pass, our sensors are at 4 feet, 6 feet, and 8 feet away from the joint. On the first pass, we were at 0.5 feet, 2.5 feet, and 4.5 feet. And the pass we just conducted before this, we were at 11.5, 9.5, and 7.5. So by conducting these passes, we've actually done straight line collection across the span of the joint, in addition to the random sampling we did from the swerve collection. So once we get to the end, we're going to scroll down, press stop and save, and we've now completed our 5-pass data collection, and we're actually ready to continue collecting as we follow the paving train operation. You can also change your data collection passes from 5 total down to 3, in which case I would recommend doing your center line joint data collection pass as well as your swerve back and forth. That gives you both the random sample of the mat covering the whole width as well as your most critical location, which is your center line joint.